if you can recollect, the equilibrium idea. So what's the translational equilibrium? So we say net force 0. And this we define along x, along y, along z. And at equilibrium, what is the state of the body? Will be at rest or will be moving with uniform velocity. Then here I'll introduce rotational equilibrium, the concept of rotational equilibrium. Here the net torque acting on a system must be 0. First of all, sir, what is a torque? What it does? It will produce rotational effect. So I want to rotate a body. I want to rotate a disc. This disc I want to rotate. This disc I want to rotate. Then what I should do? I'll apply a tangential force. I'll apply a tangential force like this. Then you see about point O, a torque is set up. R cross F. What is R? R will be like this. R bar and this F. R cross F. Then how the torque will be set up? The sense of rotation. What is the torque? Torque will be along Z axis, no? About an axis passing through point O and perpendicular to the plane. Able to get this. So what this torque will do? It will produce a rotational effect on a body, like how we have F equal to ma. When you apply force, it will produce translatory motion. When you apply torque, you'll get a rotational effect. The body will tend to rotate. So now I want to open door. What shall I do? Shall I apply force or a torque? Actually, I should apply force. Then R into F will be the torque. I think yesterday we have discussed almost maximum situations. So this is R bar, this F, R cross F. The torque will not act here. Where it will act? It will act through the axis here, the axial vector. About this axis, the torque is set up. Sir, now, so what is the torque acting now? Torque should be equal to RF. So where it will act through the point O, about an axis passing through O and perpendicular to the plane. Means now you can say like, now I'll apply one more force here. Call this is tau 1. I'll apply one more force. Then again, the torque due to that force will be RF2. What is the net torque? Net torque will be sum of these two here. Like this, what happened yesterday, we have took several examples showing that we did only for rod. Now it can be any other rigid body. Now I'll come to the rotational equilibrium. So now, what do you mean by equilibrium? Though equilibrium in the sense here afterwards, translational equilibrium and also rotational equilibrium. What do you mean translational equilibrium? Net force should be 0. What about rotational equilibrium? Net torque should be 0. Whether that equilibrium stable, unstable will determine the potential. Potential minimum, it should be stable. Potential maximum, it should be unstable. So if I say only equilibrium, what you should take? You should take both translational as well as rotational. A system can have only translational equilibrium, only rotational, or can have both. So all our numericals are just related about this particular word now. What all we discuss numericals now, they're just based on this particular word. Rotational equilibrium. Net torque should be acting on the system should be 0. Let me just take one more. Actually, we did for rod, no? I'll take the plate. Just one more example I'm just planning to give, so that then we'll proceed here. No, first let me take set of forces. So a force will act. What we should do if you intersecting x-axis, y-axis. Okay, these are the several forces I'm calling. So let me take this as F1, 10 Newton, acting at an angle 30 degrees. So let this be at a distance of L by 4. This is a square plate of length L by 2. This is F1. Let me come in order. 6 Newton. So this will be L by 6. Length is L by 4, no? L by 8. F3, 3 Newton. L by 4. F4 is equal to 6 Newton. 45 degrees. Fi 10 Newton. L by 6. F8 equal to 4 Newton. F9 6 Newton. F10 2 Newton. Okay, these are all the force acting. I'm just want talk about an axis passing through point O perpendicular to plane. This rigid body lies in XY plane. And this is one very simple best problem.
Sir, there is no F6, sir.
Okay, I'll bring one more F6. F6 is missing. No, let's get into the problem. These are the forces. So there's a square plate of side length L. This one is a square plate. I want to talk about an axis passing through O perpendicular to the plane. Okay, carry on. I'll just take out this. So what is the torque? It will produce rotational effect. Already I think I gave example of door, everything. One by one you analyze here. So how to get that force F1. So how is the force? You see that one? For that what we should calculate the angle between R bar and F bar. No? Instead what I suggest you resolve this force. Torque due to 1. Torque due to 1. Due to component of force F1x. So what is the question? Find net torque about an axis passing through point O and perpendicular to plane of lamina or anything that will be. No, what about F1? So what is the method? What you should do, you should calculate the distance, this particular distance, and after getting this, what you should do, you should, so what happen, you should calculate the angle between R bar and F bar. No, that will be very lengthy. Instead, what happen, we'll go for one very systematic approach here. Side perpendicular to plane of plate of side length L is equal to, let me take 2 meter. Now let's get into this one. So I'll talk due to individual forces. First we'll calculate. Talk due to the force one. I'll resolve the component of force F1x into L by 4. In what direction? What should be the sense? Clockwise. Perpendicular distance. Can you remember yesterday I showed you? No? So resolve that force F1x into perpendicular. What is the perpendicular distance? Will be L by 4. Then uh, F1y or again xy, lot of calculations will be directly. I'll resolve this force F1 cos 30 into L by 4. This will be clockwise. What about due to other component? F1 sine 30. What should be the perpendicular distance? Will be L by 2. I think please try to understand. This is the axis. The axis is here. So the component of force will act like this, no? So F1 cos 30 into L by 4. Then other component F1 sine 30. F1 sine 30 will act here. Then what is the perpendicular distance? You just produce it back. This will be perpendicular distance. So that will be L by 2. Now clockwise, you take it minus k cap because it lies in xy plane. Minus k cap. This will be plus k cap. So we know value of this. F1 is 10 root 3 by 2. L is 2, 4 minus k cap. 10 by 2. L is 2. This will be plus k cap. Solving this, we'll get the torque tau 1. Now similarly, let's come for due to force F2. Only force F2 is acting. What will happen to plate? Plate will try to rotate clockwise, no? Then sir, how you determine this one? So here, this you extend this force like this. So this will become R perpendicular, no? Or else what you should do, you should calculate the point where you are applying the force, the distance from the axis to the point where you are applying force. You should calculate the distance R, then angle between R bar and F bar, F2 bar, R2 bar and F2 bar. Then you should do that formula. Instead that you just extend this force. So this will become R perpendicular and this is F2. So therefore, what should be this one? The value will be F2 into L by 8. And the angle between F2 and perpendicular distance 90 degrees. What is the torque? Will be in this direction. So F2 is 6, L is 2, 8 minus K cap. This is a torque due to second force. Similarly, torque due to the third one. Torque due to the force 3. Now look at the force 3. There's an R3 bar. And how this force and this F3 bar are there? They're parallel, no? They're parallel. So therefore, what will the torque set up by this force? Will be 0, no? Because the angle between R3 bar and F3 is 0. So we do write like this here. R3 bar F3 sine 0 degrees will be 0 because the force will intersect axis of rotation. Next, again come for F4. So what you are going to do? For F4, the similar method. F4 cos 45. F4 cos for component of force along negative x-axis. What is the perpendicular distance? Will be L by 2. Clockwise. Time being, you write it clockwise or directly if you want, you can write it a curl from R bar towards F bar. Then you can see the thumb is into the plane. Into the plane is minus K cap. So here I'll just show that. Is it okay, no? One problem, if you can understand, there's a very simple idea-based problem is there. No, similarly, let's go for clockwise. Clockwise, please try to check it. R bar, F bar, it will be clockwise, no? The force F2 will try to rotate. I think you take notebook and try to push here. It will try to rotate clockwise. Next again. Torque due to the other forces. I'll proceed here now. Huh? Now this one component I got it. Now you resolve other component due to y component of force. Y component of force will be F4 sine 45 degrees. Is it L by 4 or L by 2 shall I take? It should be L by 4. And what is the sense of this? Should be clockwise or anti-clockwise here. Component of force, that when you resolve, no, that force will act like this. No, this is R bar, this R bar, and this component of force F4 sine 45 L by 4. When you extend it, will come like this here. So it will be clockwise. So both the components will set up a torque clockwise. So then in the vector form, you can write it. F4 is how much? 6 root 2, 1 by root 2, 2 by 2, minus k cap, 6 root 2, 1 by root 2, 2 by 4. Do calculations. Now similarly come for Fi. Fi will be, so that is, this is L by 6. So what is the remaining distance will be L by 2 minus L by 6. This one. L by 2 minus L by 6. And perpendicular distance how much will be? This one only. So writing this. Fi into L by 2 minus L by 6. And what is the sense? This will be clockwise. Clockwise means minus k cap. 2 if you take common, 2, this will be L by 3 it will come. So Fi is how much? 10. Okay, simplify this, 20 by 3. Okay, next again we'll go for torque due to the force Fi got all. Torque due to 6 will be 0, no? Any problem for that? The R6 bar and R6 bar and F6 bar, how they are? They are anti-parallel. So sine of 180 will be 0. What is the equation we should write? Torque due to force 6 should be F6 R6 sine of 180 degrees. So it will be 0. Torque due to 7, the same thing. It will intersect axis of rotation. F7 R7 sine of 180 will be 0. Now come for torque due to F8. This will be, you extend back this force. So this distance will be L by 6 given. You extend back this one here like this. So this will be the perpendicular distance, no? And this is R bar, this is F bar. R cross F will be anti-clockwise. So torque due to 7 will be F8, sorry, F8 will be F8 into L by 6 anti-clockwise. Value of F8, 4, 2, 6 plus K cap. Now, what are the other two forces left over? Torque due to force 9. How to do this one? You just produce back this force like this here. So as if it is acting here. So this will be R bar, and this is like F bar, no? So what is the angle between them? This will become angle. Actually, this F9 solid is acting here. Then why you are producing back just to get the angle between? So you do one thing. So why can't you do like this? This is R bar. This is F bar. This angle. Yes, you can do it. But the problem, you make it very simple. Just produce this F9 like this here. Just bring it here. Don't I'm not telling, just the line of action of force will be like this here. This will become R perpendicular, no? Then angle between them, this will be the 90 degrees. R perpendicular, angle between R perpendicular and F9 will be 90, not angle between R9 and F9. R9 and F9 will be not 90 degrees. It will be more than 90. Angle between R perpendicular and F9 will be 90 degrees. So I think it's very simple, no? So what we can write it, torque due to F9 should be equal to L by 2, or so like F9 into L by 2. What about sense? Will be anti-clockwise. Magnitude of F9 is how much? 6 K cap. And the last one, torque due to the 10. What is the angle here? R bar and F bar are in same direction. So angle between them is 0. So therefore what we can write it as? Okay, just take the vector sum. I think you'll get everything here. Now what should be the net torque acting on the system? The net torque about O should be equal to tau 1 bar why we should not use that formula? I'll calculate a resultant force, then I'll calculate effective R. So why can't we do like this? Anybody, what is the problem? What's wrong if I write it here? R bar cross F net. Is it applicable, this one here? You can calculate net force, but what is the R bar? You can't define R bar, no? So when you can write R bar F net, when you can write this formula, if all the forces are acting, if the point of application of all the forces are at same point, then this formula is applicable. I think, shall I say, it's a limited one, may not help us in every situation. Able to get this? So this is only when the point of application of all the forces are at a common point, then you have to apply it. If the point of application of different forces are different, no, then calculate torque due to individual forces and work out here. So this is not applicable. I'll take it out, this one. It's having its own limitations. Okay, this is about the general. So I took earlier rod, this a thing. So it can be a circle, it can be quadrilateral, any structure will come. Any three-dimensional lamina, one-dimensional rod, it's a two-dimensional, 3D object also will see that one. So different shaped objects are there, how to calculate it, forces will act and how to calculate a torque. This is the most essential part of rotation mechanics. You have to fight, there's no other way. It's very simple. First of all, you have to ask yourself, where is the axis?